Hey guys, so let's look here. We're first starting with sodium and nitrogen. Both of those are elements, so those are automatically knocked out. Then we're left with sugar and air. Air is a mixture because its composition is different depending on where you were to look at the air at. So, in different places on Earth, the different composition of Earth would be a little bit different. So, it's considered to be a mixture, whereas a compound is something that's going to be really, really hard to separate it into its chemical components. So sugar would be the compound there. So here we're looking at the table that provides information about a group of one elements, and it gives us the melting point of several of them, and it says which best describes the element of the melting point of rubidium, and it's asking us here, it tells us that the melting point of several of these already, and NASA's the best estimate of the new one for rubidium. And based on this, we've got potassium and calcium. Rubidium is found somewhere between them. So we can pretty much guess that rubidium, if it follows the same pattern, its melting point is going to be somewhere between potassium and calcium. And so we've got to pick a number that's going to fall somewhere between there. And so with calcium's melting point being 63 and calcium's melting point being 29, we've got to find somewhere that's between those numbers. So we look for something that's between 63 and 29. So, number three, two different liquids are poured together in an open container. Bubbles begin to form. After the bubbling stops, it is determined the two weight of the two liquids is less than before they were poured together, which best describes the observation. So, again, if you have the two liquids and you put them together, the total volume now should be equal to whatever the two were separate. So, again, whatever the two were separate, now that you put them together, that volume should equal whatever the total was before that they were put together. Well, now that you know that that's not the case, what happened to that extra volume? Well, we know that bubbles were created, which means gas was created, which means that we can say that more than likely some of that air escaped. So that would be A, because remember the law of conservation of mass says that matter is not created or destroyed, but it can be transferred from one form to the next. Now, we can also say here, looking at the law of conservation of mass, that also comes into play with number four. This is a chemical reaction for the composition or decomposition of carbonic acid into water and carbon dioxide. How does the reaction support the law of conservation of mass? Remember, that's telling us that matter is neither created nor destroyed, but it can be transformed from one form to the next. And so, what I would do here is it gives you your chemical equation H2CO3 yields H2O plus CO2. So first, what I would like to do is make sure that your chemical equation is balanced. So I would list out the elements that I have on the product side, which is the left side, and then the reactant side, which is the right side. Or actually switch that, reactant side on the left, product side on the right. And once you have listed that out, seeing if they are balanced. And if they are balanced, then you would go to see and look what that means. Well, if they're balanced, then that means the law of conservation of mass is true, that you're having the same amount of mass on both sides. So for that case, C is the answer. The mass of the atoms in the reactant equals the mass of the atoms in the product. So what was on the left was what was on the right, basically, which is what the law of conservation of mass states. All right, so five says which best describes the method of obtaining energy that may cause changes in water temperature and harm to fish populations. So again, we're looking at something that is going to change water temperature and harm fish populations. So ethanol in cars isn't going to do that. Installing solar panels is not going to do that. Generating electricity in a hydroelectric power plant, now that could possibly do that. And then looking at burning coal, now that could also do that. So we're looking at which one's going to be the best there. So our best one there is going to be burning coal. Again, that's going to increase greenhouse gases, which is in turn going to increase water temperature. So, which is a non-renewable resource. Again, non-renewable means it's something that's not replaced in a short amount of time, and that would be oil. And how would a large increase in the salinity of an estuary most likely affect the ecosystem of the estuary. Remember, that's looking at the area where a river meets the ocean. So we're talking about an increase of the level of salt. So what would most likely affect the ecosystem of the estuary when that happens? So the number of salt tolerant organisms would increase and the number of salt intolerant organisms would decrease, right? Because again, there's more salt, so more salt loving animals would live there. All right, so which would indicate the water in the lake is not safe for drinking? Again, this one is D, high turbidity levels in the lake. Remember, turbidity talks about how clear the water is. And again, that's not the only indicator, but that's a really good indicator as far as the healthiness of the lake, how clear or not clear the water is. A geologist identifies D for 9 identical index fossils in rock layers from two different areas. Which conclusion is best supported by this discovery? And you could say the two rock layers were deposited at approximately the same time. So again, remember, index fossils are fossils that help you determine when something was buried, when something was alive, right? They're kind of like what you judge other fossils by. And which supports the theory that some mountains were once at the bottom of an ocean. And that's again the fact that C, fossils of marine organisms were found at the top of some mountains. And that would definitely support that theory because, again, how did those ocean critters get there, considering they don't have arms and legs to be able to climb up or survive at the top of a mountain? So they had to have gotten there somehow.